What's up, you guys? So in the last two videos, we discussed speciation, which is when one species diverges into two new species over evolutionary time. This can be seen in a phylogenetic tree when one branch splits into two branches. Something else that can be represented on a phylogenetic tree is extinction. Extinction occurs when one species ultimately dies out and ceases to exist. This can be shown on a phylogenetic tree when one branch stops before it reaches the end of the tree, with the end of the tree representing present day. Extinction is something that is inevitable in a changing world, and is particularly rapid in times of ecological stress. It is also predicted that 99.9% of species that have ever existed on Earth have gone extinct. A mass extinction is one where at least 50% of living species on Earth go extinct in a relatively short period of time. According to the fossil record, there are a total of 5 mass extinctions that have ever occurred in Earth's natural history. These extinctions are the Ordovician, Devonian, Permian, Triassic, and Cretaceous extinctions. Because the Permian and Cretaceous mass extinctions are the ones that tend to get the most attention due to their relatively high death rate and/or nature by which the extinction occurred, we will only discuss these two in this video. The Permian extinction occurred approximately 252 million years ago, leading to the death of about 96% of all marine animal species and 70% of all terrestrial life on Earth. Because of this massive death toll, the extinction has also been referred to as the Great Dying. The Permian extinction was initiated as a result of widespread volcanic eruptions in the region that is presently known as Serbia. In addition to the lava killing many organisms near the volcanoes, the eruptions also released noxious gas and carbon dioxide into the atmosphere. The rise in atmospheric CO2 levels led to a rise in global temperatures by about 6 degrees Celsius due to the greenhouse effect. As the Earth warmed, the difference between the oceanic temperature nearest to the equator and the oceanic temperature nearest to the poles decreased. This gradual loss of a temperature gradient led to less oceanic water mixing, which in turn led to a widespread drop in oxygen levels within many parts of the ocean, thereby killing most marine animals. The drop in oxygen levels in the oceans also led to the increase of anaerobic bacteria that released a toxic byproduct known as H2SO4. This gas bubbled up out of the oceans into the atmosphere, leading to the formation of acidic rain that would ultimately kill the majority of terrestrial life. So in summary, the initial volcanic eruptions led to a cascade of events that scientists predict occurred over the span of less than 500,000 years, perhaps even as little as just a few thousand years. The other mass extinction that gets a lot of attention is the Cretaceous extinction, which occurred approximately 66 million years ago. It was during this time that nearly all dinosaurs and just under 50% of all marine life went extinct. Although the dinosaurs were on the decline for other reasons leading up to the extinction, it is predicted by scientists that an asteroid collision with Earth was the ultimate reason for this mass extinction. Evidence for this collision includes a large crater discovered near the Gulf of Mexico and a layer of iridium, an element commonly found in meteorites but rarely found on Earth, discovered within a thin layer of clay that dates back to this approximate time frame. In addition to the 5 mass extinctions previously mentioned, some scientists believe that we may be currently entering a 6th mass extinction, largely due to human activity. Things such as deforestation and rising atmospheric CO2 levels have led to changes in various ecosystems, which in turn has led to a large number of extinctions. Just within the past 400 years, over 1,000 species have gone extinct, which is about 100 to 1,000 times the normal rate of extinction according to the fossil record. As a final note, the phenomenon of adaptive radiation can also occur after an extinction. Adaptive radiation is when one common ancestor species diverges into many different species to fill the newly available niches or roles within an environment. When the Cretaceous extinction occurred, for example, and nearly all of the dinosaurs died off, many new niches, such as those of large predators or large herbivores, became available. Small ground-dwelling mammals that survived the extinction were then able to evolve and speciate over long periods of time until many of the niches previously occupied by dinosaurs were occupied by mammals. That's the end of this video. I hope it was helpful, and if you have any questions about the topic of extinction, feel free to leave them in the comments section below.